This is GM Word of the Week, and I'm Fiddleback. Cloud Forest. We've mentioned before that we aren't exactly spring chickens here at the Word of the Week. And one side effect of getting old in our current age of reboots, remakes, and retcons is that we are constantly encountering people who think of some remakes, or reboots, or whatever, as the original. They get excited, for example, about the movie about the dinosaur theme park, and we embarrass ourselves by getting wrapped up in nostalgia for something published when the person we're talking to was a zygote. For example, the current generation of people who need to get the heck off our lawn thinks Jurassic World was a pretty good movie about a dinosaur theme park, and we have to make them sit down and watch Jurassic Park, the real movie about dinosaur theme parks that is two terrible sequels removed from the mediocre remake they think was a good movie. It only gets worse when the movie that spawned the remake was a book first. See, our fond memories of Jurassic Park don't start with a 1993 science fiction blockbuster movie directed by Steven Spielberg. They actually start with a book written by the late Michael Crichton in 1990. This is the obligatory part where we swear to you this is all related to the word of the week, which is Cloud Forest, by the way. Michael Crichton was a true science fiction author. That is to say that his novels were loaded with hard science, and the more fanciful parts of the book were based on what-if scenarios assuming the current science of the day was advanced a little, and then cranked up to 11. If you weren't a science wonk, like we are, you might be a bit put off by the fact that every one of his characters was an expert in some field they just loved to explain ad nauseum. But if you love science, like we did in our teenage years when we discovered Crichton, you were fascinated by all of the information drops in his books. And, at least, he dropped them into the narrative for the most part, and didn't just get distracted with pages and pages of digression where the author himself just breaks into the book to deliver an essay on, say, the failed sewer system in Paris, or the terrible social failings of convents and nunneries, like certain certain authors we might know. Seriously, never try to get through Les Miserables. Michael Crichton was a fascinating author. In a way, he was a true Renaissance man. He educated himself about everything, and then wrote amazing books to pass his information on through exciting, thrilling, and informative science fiction tales. And sure, the science in his first book, Andromeda Strain, is very dated, but there is still a great story in there. And Sphere is a fascinating look at both the underwater biological world and the problems the Navy faces building undersea habitats and installations and just working under the sea. And that was the book that taught us what amazing, emotional, and intelligent creatures octopodes are. Yes, octopodes. See, octopus comes from the Greek, not the Latin. And that thing of adding an I at the end to make an irregular plural is a Latin construct. The proper Greek way to make the plural is to change the pus to a pod. Of course, octopus sounds like it could be Latin, but in Latin, that name would mean 8 corruptions. The Latin way to say 8 legs would be octopod. Admittedly, eightfold corruption is a really good name for a tentacled horror from the deep. So maybe the Latin octopus is way cooler than the Greek octopus. But we digress. In the book Jurassic Park, a genetic research company figures out a way to clone dinosaurs by extracting genetic material from fossilized blood-sucking mosquitoes. And they decide to use this technology to create a theme park, unapologetically. Crichton even points out that almost every new technology ever invented is either co-opted by the military or used for entertainment first. That's where the money is. Suddenly, the dinosaurs go berserk and break free and start killing people. But there's a lot more to the book. Like the discovery of how the dinosaurs are breeding, and how they have to invade a velociraptor nest to count the eggs to determine if any raptors have escaped the island. It's a great book. Read it. But among the many, many fascinating digressions in the book is what amounts to a travelogue for the Republic of Costa Rica. Costa Rica, whose name translates to the Coast of Riches, is a Central American country which is biologically one of the most fascinating places on Earth. Why? Because Costa Rica is rich in biodiversity. And what does that big old word mean? Well, although Costa Rica is tiny and takes up only 0.03% of the world's surface, yes, that's 0.03% of the surface of the Earth, a whopping 6% of all the species on the Earth are estimated to be represented somewhere in Costa Rica. How can such a tiny country hold such a broad variety of life? It's because Costa Rica has very varied geography. Or rather, it has a very varied climate. It all comes down to biomes. Biomes are regions of the world with similarities in climate, flora, and fauna. Flora and fauna are, of course, plants and animals. Now, you've heard of biomes before. You've heard of deserts and tundra and grasslands and forests, right? Those are biomes. Now, it is tricky to discuss biomes because, even though they are basically a biological fact of life on Earth, no one really agrees on one list. The broadest classifications include only 5 biomes: aquatic, desert, forest, grassland, and tundra. And those classifications are further broken down into more detailed classifications. For example, forest biomes include tropical rainforests, temperate forests, and taiga or boreal forests. Deserts come in hot and dry varieties, semi-arid, coastal, and cold desert varieties. These can be broken down even further. One of the most detailed lists we turned up includes 14 biomes: freshwater wetlands, marine, coral reef, estuary, tundra, rainforest, savanna, taiga, temperate forest, temperate grassland, alpine, chaparral, and desert. But however you break down the list, you pretty much cover the same ground. And the ground here is all of the ground on Earth. And, thanks to aquatic biomes, all of the oceans on Earth. The thing with biomes, which literally just means where life happens, is that although it seems like the plants and animals are the important bit, they really aren't. What makes a biome is the reason for the plants, for the animals, or lack thereof. It's the climate. We tend to use the words climate and weather in the same breath, but climate is bigger than weather. Climate creates weather. Climate is an overall prevailing weather pattern. You could live in a warm, wet climate, even if it is chilly and dry today. Biomes are defined primarily by their climates, and the plants and animals that live there are the plants and animals that are suitable for that climate. Lots of things affect the climate of a region. Climate, humidity, wind, water patterns, elevation, and so on. And if you combine climate with a few other factors like how nutritious the soil is, you'll find you get similar plant life in a region. And similar plant life leads to similar animal life. Thus, climate is the beginning of every biome on every list. Take forests, for example. Forest biomes cover about 1/3 of the total land area on Earth, and, interestingly, contain about 3/4 of all the biomass on Earth. That is, if you weighed all of the organic chemicals and all the living things on all the Earth, about 70% of that weight comes from forests. The first forests appeared about 400 million years ago as colonies for the first green plants spreading across the land. Scientists describe these ancient Silurian forests as dominated by mosses, horsetails, and huge frondy ferns that stood 40 feet tall. Today, we break forests down into 3 different basic categories, which is based primarily on how far north and south of the equator we find them, because that affects their temperature and seasonality. Tropical forests, closest to the equator, are generally warm and usually have only 2 seasons, wet and dry. Half the day is spent in sunlight and half in darkness, and that varies very little. Temperate forests occur in most of North America, Europe, and a lot of Asia. They have 4 nice, well-defined seasons, and the temperature varies from cold in the winter to warm in the summer. Boreal forests, also known as taiga, cover the most land area of any single type of biome. They occur well to the north in Scandinavia, Siberia, Alaska, Canada, and other northern places. They have short, moist summers and long, cold, dry winters. But even within biomes, we can get a lot of variation. And that is what brings us around to Costa Rica's rich biodiversity. And that also brings us around to the word of the week, which you might never have heard of, along with a related word that you probably have. Let's talk about rainforests and cloud forests. Well, specifically, let's talk about tropical rainforests. Tropical rainforests are warm, wet tropical forests that, due to a weird quirk, do not actually have a dry season. And that quirk has to do with something called the doldrums. And doldrums are a bane to sailors everywhere, at least true sailors, the ones that sailed sailing ships. A doldrum is an area where the wind patterns are erratic and often where there is no wind at all. Now, this is a highly technical point, but sails need wind to go. Without wind, sails, and thus the ships they are attached to, just sit still. And there just happens to be a band around most of the world called the Intertropical Convergence Zone, where 2 different major prevailing winds crash together and sort of cancel each other out. Now, winds drive weather. Winds push moisture around the world. With no wind, climate patterns tend to be very invariant, especially in the tropics, where temperature is also pretty invariant. And the end result is that in forests in the Intertropical Convergence Zone, everything pretty much stays the same. It's hot and humid pretty much all of the time. So what happens is, all that water warms up and evaporates and rises up, and then as it rises, it condenses back into water and falls again. And you get nearly endless rain. Tropical rainforests are one of the richest, most diverse types of microclimate on Earth. And they are extremely complex, because within the tropical rainforest there are several distinct environments. At the very tippy top of the rainforest is the emergent layer. This layer consists of a very small number of extremely tall trees that grow far above the rest of the rainforest. Eagles, butterflies, bats, and monkeys call this layer home. And they have to be very hardy to withstand the high temperatures and the occasional strong winds. Most of the trees in the rainforest, though, grow to pretty much the same height, usually between 100 and 150 feet. And these trees grow thick and close together. And oddly enough, this thick layer of interconnected treetops, called the canopy, is where most of the life in the rainforest is actually found. In addition to the trees themselves, many clinging plants attach to the trunks and branches of the canopy layer, collecting water and minerals from the air or from the trees themselves. Many insects, bats, primates, rodents, snakes, reptiles, and other creatures that can climb and jump and fly live in the canopy layer. Below the thick canopy is an area of larger leaves and thicker branches. There are many fewer clinging plants here, but larger animals and predators call this layer home. Jaguars, leopards, large snakes, lizards, and birds hunt and leap and fly and climb and prowl the understory layer. And finally, far below is the forest floor, and this is probably the most mischaracterized of the layers of the tropical rainforest. We tend to think of this place as choked with ferns and vines and almost impassable without a machete, like a typical jungle. But the tropical rainforest floor is generally very clear, and that's because the canopy is so thick that only a tiny fraction of the sunlight that falls on the canopy ever reaches the forest floor. Once you get away from rivers and swamps, where more light can get through because of breaks in the canopy, the only stuff that can grow here is stuff that doesn't need much sunlight. Molds and fungi are common here, where the heat and humidity promote decay. Animal waste falling from above provides plenty of fertilizer for molds, fungi, and small hardy plants. But it isn't just the tropical rainforests of Costa Rica that help give it such a rich biodiversity. Costa Rica has numerous microclimates and variations on the theme of tropical forest. and one of the most stunningly beautiful is the cloud forest. See, if you take the same sort of conditions that create a rainforest, and you put it up on the side of a mountain, where things are a little cooler, and where they can snatch some moisture from the winds as they go by, you get a cloud forest. A cloud forest is a cool, elevated mountain forest with lots of ridges and valleys that is perpetually shrouded in the mist and fog of semi-condensed moisture. Because of the humidity, everything tends to be covered in hardy mosses, and they are sometimes called mossy forests. They have also been called elfin forests because of the ghostly shroud of perpetual fog. The conditions that create cloud forests are rare and special, and only 1% of the world's forests are considered to be cloud forests. But the definition of what constitutes a true cloud forest varies from nation to nation. And just as with rainforests, there is a temperate cousin called the temperate cloud forest that some nations don't even consider to be true cloud forest. But what makes cloud forests special, apart from the splendor of a tropical mountain forest filled with ethereal fog, is that they are a highly specialized environment, and there are things that can only live in cloud forests. Rare flowers, unique insects, lizards, and birds all call cloud forests home. And Costa Rica's famous Monteverde cloud forest is estimated to be home to 400 species of birds, 100 species of mammals, and 1,200 species of amphibians and reptiles. It is also home to a rich diversity of hunting cats, including jaguars, ocelots, pumas, onslaughs, and margays. How do you use all of this in your game? Well, obviously, an understanding of climates and biomes is rich fodder for world building. But the reason we bring it up, and specifically why we bring up Costa Rica, is that we recently ran a campaign set in a coastal nation, and because Jurassic Park told us what an amazingly rich and varied natural environment it was, we based it on Costa Rica. And that's actually a great way to create a setting for your campaign. Pick a country and learn about its climate, geography, and the types of animals that live there. The thing is, when we plunk down these symbols on a map, forest, grassland, mountain, hill, or whatever, we lose sight of how rich and varied such things can be. Costa Rica, on a D&D map, would be just covered in little green trees and little brown triangles for mountains. But those little green trees represent soggy mangrove forests, dense jungles, massive rainforests, and mysterious cloud forests. But even on the smaller scale, a location like a cloud forest is great inspiration for a single adventure. A majestic, mysterious, magical forest filled with cloud and shadow and home to unique plants and animals? Imagine a quest to heal a terrible illness with an orchid that only grows in the cloud forest. Or a visit to a mysterious, wise, and ancient cloud dragon who dwells deep within one of these ancient elfin forests. Inspiration is everywhere in the natural world. Use it. This has been the GM Word of the Week. It was written by the Angry GM and recorded and produced by me, Fiddleback. You can find more at theangrygm.com and madadventurers.com.